You know that our Earth goes through various cycles, changes, and rotations to make the climate of each part of land. The distressing part is that these cycles have lately become alarming for us. Earth has various parts that experience extreme winters throughout the year, and soon the whole world can experience these winters in the same pattern. Hello, and welcome back to The Door to the Universe. Today, we'll take you through the journey of climate change. The journey of understanding these patterns and dangers of these alarming climate cycles in the near future. Most people know that Earth gets seasons due to the tilted rotation of our planet with respect to the Sun. Half of the hemisphere of Earth points towards the Sun and experiences warmth, while the other half points away, experiencing cold, and making different seasons in different time zones. Similarly, there are few parts of the Earth that experience the same climate throughout the year. Such lands are placed on the upper or lower tilt, close to the equator, and barely get any effect of rotation as the distance from the Sun remains consistent. Talking about the tilt of the Earth, neither is it a static figure nor the only factor that decides the warmth or cold of the Earth. We are familiar with the basic model of the solar system and how all the planets, including Earth, circles the Sun in a fixed orbit or a flat plane. This model also represents that we circle the Sun in a fixed orbital plane because of the Sun's gravitational force, which is the partial truth. In fact, the Sun is not the only gravitational force body that holds the Earth, although it is the most impactful. Many other planets, such as Jupiter and Saturn being huge masses, pull on Earth, helping it to hold a place in orbit. Since all the planets rotate and circle around the Sun at different speeds, the gravitational pulling of planets on each other is not consistent. The planets keep pulling and releasing each other on different levels, creating different circles closer and farther on the orbital plane. Hence, the model representation becomes way more complicated than differently sized circles around the Sun. This situation of increased and lessened pull and release impacts various factors of our place of the elliptical, tilt angle, and the shape of the orbit. Basically, these variables of conflicting speed and mass are stabilized into cycles that were first explained in 1920 by Milankovitch, a Serbian geophysicist and astronomer. Let's talk about the first Milankovitch cycle. This cycle explains the changing shape of our orbit. Over the period of 100,000 years, the orbit of Earth became more and then less elliptical. If our orbit is closer to the circular path, our distance from the Sun would stay steady, and the Earth must get the same amount of sunlight for the whole year. Nevertheless, when the orbit becomes elliptical, there are few parts of our planet that became farther from the Sun and hence experience cold. Similarly, in this elliptical situation, the parts of Earth closer to the Sun experience the warmth and hence summer. This results in perihelion and aphelion, where the Earth is closest to the Sun roughly on 3rd January and where the Earth is farthest from the Sun roughly on the 4th of July, respectively. Although the cycle of Earth's revolution around the Sun is more circular than elliptical, Earth still gets a 7% difference in the proportion of sunlight received in January as compared to July. This difference in the sunlight percentage means that the northern hemisphere experiences warmer winters while the southern hemisphere experiences warmer summer and colder winters during this phase. The 7% sunlight of the current Milankovitch cycle will turn into 23% in the near future. This will occur when the revolving circle becomes more elliptical. Moreover, this increase in the difference in the percentage of sunlight will result in colder winters and hotter summers in the southern hemisphere, while the northern hemisphere gets a more stable cycle with moderate summers and winters. This might seem like an extreme condition, but the other cycles are also playing their part in stabilizing the climate. Slowly and gradually, the tilt angle Earth is rotating along is shifting as well. Although the axis of Earth is currently parallel or pointing toward the North Star or Polaris, the axis will eventually point toward other stars in the future. What is more interesting is that the axis will go back toward pointing toward Polaris or the North Star after the completion of the cycle. In 13,000 years, the Northern Hemisphere will be having summers mostly in January, while the Southern Hemisphere will be cold during January. Not only that, But there are the Milankovitch cycles resulting in winters that last for not only one, but hundreds of years. These cycles are the ones to help with ice ages of Earth. There is no clear and accurate explanation of how ice ages occur and end, but the books are full of theories. However, the fact that these ice ages have been lining up pretty well for hundreds and thousands of years must have a fixed method or pattern. For example, there is a cycle in which the flat plane of the Earth falls and rises over the period of 100,000 years, making a circle revolution within the circular plane of orbit. Although this circular orbital inclination does not fully explain the concept of a hotter or colder atmosphere, as the Earth's distance from the Sun still remains the same, it lines up so precisely with the occurring and ending periods of ice ages for the last 800,000 years. So, the scientific overlap concluded that there might be a connection between the inclination of orbit and the ice ages. Moreover, the cosmic dust present in the plane of Earth's orbit repel some of the sunlight in some inclinations. We can use this phenomenon to somewhat explain the occurrence of ice ages. One way or another, there has been a cycle that influences or makes patterns for the occurrence of ice ages on Earth. The tilt angle of Earth's axis alternates from 21.1 degrees to 24.5 degrees over 41,000-year periods. Currently, the tilt angle is 23.4 degrees and gradually declining. However, the decline of this tilt angle will lead Earth to more spreading of the ice sheets on land and a colder atmosphere. This scenario, if continued, will hit its peak in 9,800 years. Surprisingly, the mildness of the summer has a much greater effect on the spread of ice sheets than the harsh winters. Simply, winters cause the ice or snow to stay on top of the mountains and glaciers. However, summers tend to melt it down. So, the ice must form in winter at all costs, but the mildness of summer causes it to stay in the atmosphere of Earth. The icy snow is white in color and hence reflective, as white absorbs zero to the least amount of light, or more specifically sunlight thrown at it. So, if the Earth's outer surface is covered with ice sheets, the sunlight is reflected back and the atmosphere becomes even colder. Right now, Earth is in an interglacial period, which means we are experiencing abrupt moments of warmth that may last only a few thousand years, slowly going toward a cold lifestyle. Actually, if it was not for the mild summers and warmth uptick, we would have to live in an ice age right now. Although we somewhat are in an ice age right now, not a full one to change the entire perspective of our atmosphere. There are multiple other factors in the space directly impacting the atmosphere. So let us know in the comments which ones you want to learn about next. Don't forget to hit like and subscribe to never miss an update.